All right, happy Sunday, everyone. I really appreciate you guys tuning in. And let's see who we all have here. I have Joe, Brooks, Carrie, Mark, and Kimberly. Yeah, I really appreciate you guys attending this this live stream. So I was on Mark's live stream last week, and I made a couple comments about Fusion 360 and V-carving and some of the restrictions that it has. And when I was saying some of those comments, it was geared towards V-carve inlays. And the problem that Fusion has is it can't model it, very correctly, especially if you have a deep pocket going down. And when you put the angle in and you model that, the model gets kind of construed and it will air out, and there's a lot of issues with it. So I set out today or earlier this week to just kind of go through all the steps and model it correctly and see some of the challenges that you have when you start doing the V-carve. And I'm not saying it's impossible, but it sure is on the line, especially if you have an intricate design. And what I'm going to go over, and this is in preparation to do a wavy flag, and I'm going to show this wavy flag one more time. So these stars right now are cut in, and I painted the bottoms. And I used my laser to do this, and it built a curvature, so the stars are very uniform. What the going trend is right now, people want to see those stars inlaid into the piece. And there's some problems that people come into. Issues arise when you try to do that. And it's all about the angle that the V-carve or the male insert goes into the material in relation to the curve. And what ends up happening is the star will get bowed out and it won't be uniform. It won't look like a star when you look at it from the top down. Now, depending on how big the star is and the curvature of the surface, it almost looks like it's following the curvature. But when you look at it from the top down, you really notice it's deformed and it just doesn't look like a star. And there's a couple tricks in Fusion we'll go over on how to make it look like a star, and it will hold the parameters of the overall width dimensions of that star relation to the surface. So I'm going to pull up Fusion 360 here in a second, and we'll kind of walk through some of the challenges and the workflow to actually make that happen. Now, with this live stream and the time constraint that we have, I can't go over an intricate design and how to make that work. This is specifically geared towards making the actual star and inlaying it as a deep pocket onto a curvature. So I'll pull up Fusion right now and we'll see what the actual challenges are. So I ended up doing two versions, and this is just a 3x3 blank test that I'm going to be doing as soon as we get done with this. I was going to do it yesterday, and I ran out of time and I had some issues with my machine. So got that stuff resolved. I'm going to do this right after the live stream, and then that'll probably be my next video for like the entire steps for the design, and then getting into the garage and actually doing it with different tool paths and capturing all that. Disclaimer on this. So this test file, I'm going to put this on my Patreon. I'll link the actual link in the description and the comments of this video, where you can go to my Patreon. You can find it. It's for free. You'll have to join as a free member, but it doesn't cost anything. I don't know if anybody's ever been on Patreon, but it's a good platform to share. And then I also put all my files where you can purchase them, and they have varying prices depending on the difficulty of what I have. But this one specifically will be completely free. And then if you want to walk through the tutorial that I post, you can walk right through it. So, okay, so let's get into this. So this is a 2D version of the star. This is a 3D and it captures a wave. So it's an uneven surface. And you can notice that the stars are equally the same. Minus, I put a radius on this 2D version. And there was a reason why I did that, because this version, when I cut this out, I'm going to use a tapered end mill, or tapered ball nose. And I'm going to use a very fine tip. The taper on this is 6.2, and the tip of the ball nose is a 64th in radius. This 3D version, I ended up using an engraving bit, a 30 degree engraving bit. It gave me a 15-degree chamfer on each side. And I did that to get the points. So there's two versions here. You can do it with a tapered end mill, or you can do it with an engraving bit, and you get the same results, but how it interacts with the surface is a little different. The reason why I went with an engraving bit on this is my ball nose would have an issue trying to gouge in, and I would have to account for that radius of the ball nose. So this is a little bit easier, and I'll kind of explain the limitations on Fusion that drove me to that conclusion. And it really came down to the geometry and the differences on how the bit interacts with the overall sketch or that edge. And so a couple of limitations there, but at the end result, we'll see how how this actually everything looked really good as far as the simulations, and we'll walk through a little bit of that. But I'm very, very interested to see with physical material, how the bit interacts with the edges and how tight those seams actually are. The goal is to have zero gap, no gap at all. So let's just we'll baseline this. So let's check the section analysis on this. So you can see that I purposely left a glue seam on the bottom of this joint. You can see that where it intersects with the male portion, the plug, and the female version, everything lines up for that curve of that surface. On the bottom, when it gets sandwiched down, I left 0.01 of a gap for glue squeeze out. Now, I don't have a lot of history doing V-Carve inlays and the exact amount of gap that you should have and the tolerances between that. But I can adjust this depending on the results that I have, where I can adjust it later if it just doesn't work out, or if I need a larger glue gap or a smaller one. It all depends. So when I do these test cuts today and everything's glued and everything is flat, I'm probably going to go ahead and I'm going to cut this board in half, and just to see how the plug interacted with the female, and we'll see. So hey, Brooks, kind of remind me with the questions. Definitely leave your questions in the comments, and I'll address all of them. I'll try to get through all of them before we end the live stream. So Brooks, my original thought is to create a V-Carve inlay before the wavy carve. So let's walk through that. And that is the main reason why the star will come out deformed. And it all matters on how the degree chamfer that you put on the plug interacts with that 3D surface. And depending on the surface, when the plug goes in, it will get deformed when it tries to go down into it, because it's entering at different points, and the chamfer is still there and is still valid. So let's go ahead and we'll replicate that really quick. So I'm going to hide all this stuff, and let's just do a sketch. I'm going to keep my original box of a 3x3. And then we're going to make this 0.75 thickness. So we'll extrude this up to 0.75. My section analysis still on. All right, let's make this 0.75 thickness. And then I already have the star laid out. So let's go ahead and we'll bring the star outline. Right now it's just a little, it's right on the surface. So I'm going to go ahead, I'm going to hide this body I just made, and I'm going to extrude this down. Let's go 0.3, 0.4. And with this, since we're going to use a 30-degree V-carving bit, I'm going to take this tapered angle. I'm going to put it at 15 degrees negative. Let's go negative 15. All right. So actually, let's bring this down just a little bit farther. Let's go all the way to like 0.7. I'm going to hit OK on that. Now, what I'm going to do is I'm going to bring this body back that I just made. And I'm going to put my 3D plane in, and I'm going to cut the actual surface out. So I'm going to use the split body. I'm going to select this body to split, and then my mesh for my curvature, I'm going to extend it, hit OK, and then I'm just going to go ahead and I'm going to remove the top portion. So there's the plane that I have that I want, that surface. And then I'm going to bring in this star. And you can see that it's already in the surface, right? Because I went 0.7 down. But because it's constrained at a 15-degree angle, that angle enters this surface at a different degree. So what I'm going to do is I'm going to cut this into it. So I'm going to go to combine, and then the target body, and then I'm going to cut. I'm going to use this star with the angle that I want. I'm going to keep this tool. I'm going to hit OK. So now I have the angle that I want, that 15-degree chamfer. It's cut into the material. And what I'm going to do is, I'll do that later. But because I cut it at a chamfer, you can see the outside line and how it interacts with the surface. It entered at a different point in time on the actual surface, and it deformed that star and how it looks. Now the bottom of the pocket, because it's flat and it interacted with that body and it was flat, the star isn't deformed at the bottom. We don't want that. We want to keep this constrained to how it enters into the surface. So to bring this up, to visualize it, let's go ahead and I'll cut this star profile with the mesh. I'll extend it. That's fine. I'm going to delete this. So there's the star inlay. And you can see that this is just a little bit wider. This isn't perfectly flat or perpendicular to the surface. And yeah, so let's put some material or appearance on this so you guys can see this a little bit better. Okay, so I went from this, and let's move this out. So we'll select this. I want to move this over. Let's bring in our 3D version. Let's get rid of that. All right. So looking from the top on that surface, you can see that that star is 100% deformed and it doesn't hold its shape. And the hardest part too is I wanted to keep this a certain distance. I wanted the star to be, and especially with American flag, and those dimensions are very by regulation, where they sit in the union. And if you get deformed stars in there, it doesn't look right, especially when you add 50 of these at all different intersections of that surface. And the spacing's off, the size of the star are all different. And it's all due to how that chamfer enters into that surface. So that's the main reason why those stars are deformed. Now, to get around that, we have to do some interesting things. Um, and so, and we'll walk through it. So, I'm going to delete. Well, actually, I'm going to keep this. And what I'll do is we'll redraw this. So I'm going to do the same workflow. I'm going to create that body. We'll do a 3x3. We'll put some thickness on it. I'm going to cut the profile out on it. Let's go to the split. Body to split. My mesh. I'm going to extend it. I'm going to go ahead and remove this. Now I'm going to bring back my star outline. And you can see that because I removed a whole bunch of material with the wave, that it sits just above the working surface of that curvature. So I'm going to go ahead and hide. We'll hide this. Bring this back. And I'm going to go ahead and I'm just going to cut. Actually, well, let's do this. Let's just bring this down. Let's go. That looks about a good depth. Let's go 0.45. All right, let's just cut it in. Actually, yeah. Because it's straight up and down, I didn't put a chamfer on it. The star is 100% constrained within the overall dimensions. And when it entered in straight down, it held that form. Now, the only thing that's different is the curvature of these lines and how they interact with the surface. They look deformed when you look from an angle, but from the top up, from top down, it's 100% exactly the dimensions that you want for the star. And now here becomes the issue. How do I make the plug interact with that surface at an angle? Fusion has some limitations on this, but what I found specifically with just the star, and the star, this drawing isn't curved, it doesn't have splines, it is very straight angled, and that becomes very, very important when you start doing a larger design or something that has a lot of curvatures. Fusion will automatically have an issue trying to project the angle that you want to set based on the overall outline of that surface. And so we're going to concentrate on this surface and not this. Just because I know that this surface right now is constrained by that sketch and how it interacts and cuts into it. So let's go ahead and I'm going to go ahead and create the male plug based off of this angle that it's cut at. So I'm going to extrude this up and I'm just going to pull it straight up. I'm going to make sure that it's a new body. And then what I'm going to do is I'm going to use the same mesh. I'm going to cut that star out. So split body, I'm gonna select the star. I'm gonna go to the um, the mesh, and we'll just extend it, and then I can remove this. Okay, there's my male plug that I need. The the challenge is to get an angle based off of this curve that interacts with this 90-degree angle. And what we're going to use is the draft function. And this is a very, I think it's an underdeveloped tool in Fusion that's not utilized very rapidly. But I was able to make it work to constrain this curve and the interaction with an angle taper for that side. And so that's another thing that I really wanted to bring up too is I'm not angling it from here to here. I kind of am, but I'm not. I am angling this face at whatever degree that I'm going to cut it at. And in this case, we're going to use that 30-degree V-bit. So let's go ahead and draft this really quick. So in draft, you have two types. You have a fixed plane and you have a parting line plane. We're going to use the parting line, and the push-pull direction that I need to angle off of is this bottom base to give me that 90-degree constraint. The parting tool is what I don't want it, where it anchors down, so I can push that face inwards. So with that, it's going to be this entire profile of this curvature. In the parting line type, it's going to be fixed. So that means it's not going to move. Nothing's going to happen to that edge when I start playing around with this. Now for the faces, we're going to select all, and this thing. Let's do, give me a second here. I don't want to do it individually. I want to do all of them. So actually, let me select the faces first. All these faces are going to have a chamfer of 15 degrees. Push-pull direction is going to be the bottom of this. And then we need to constrain that parting line. You. Now, hold on. Let's do this. What's happening right now is it's only letting me select one. So essentially what I'll have to do is I'll have to do it individually by face. And I don't want to do that. I want to do it all in one shot. So let's go back. And it could be I just need to restart Fusion. I've been working on Fusion for like 3 days straight on doing some other design work. And if there's something that gets hung up, you just automatically restart and then it'll kick back in. But I'm not going to restart for this. Parting line, let's do this. And then the pull direction, we'll do this. All right. Now it gave me an error. And one of the reasons why I did this is it doesn't have enough room when it goes down to do this angle. And it's more than likely this edge that's giving me that problem. It's just because it's not as, it needs to come down farther. So I'm going to hit cancel on that. And I'm going to drop this down more. Actually, I need to bring it up. Let's try it down. This is probably one of the most frustrating tools that you can use in Fusion to get this thing to work correctly. All right, let's try this one more time. All right, there is my 15-degree chamfer that's constrained by that curve. And that will put my plug in at 15 degrees all the way around the entire plug. And when it goes down into it, it gets sandwiched in between the female version and the male version of that plug. And as it goes down, it starts to get really, really tight. And the edges will conform a lot better than whether it was just a straight angle down. I've seen a lot of people put different tolerances for a straight angled inlay. And depending on your tolerance, whether you're going to have to use a ton of clamps and risk breaking the material or taking a press and pressing it down. And again, there's still a gap in there. The V-Carve inlays, when it goes in at that angle, it sandwiches itself down and it will swell, especially when you hit it with glue. That swelling tightens everything up, and you should, if it's done correctly, have a very tight seam on the surface of the female version. So I'm going to hit OK on that. And there is my angled plug that I'm going to use. Now you can see that it really deformed the bottom, but I would rather have it deformed on the bottom than on the top. And it's all due to that constraint. And I actually missed an edge, this edge. So let's go ahead and we'll go back in and fix that. So we'll go back to our draft. We will pull from the bottom. We'll use this face, and the parting will be this edge. And I'll give you my 15 degrees. All right. I think I hit all of it. So there is my star. Now you can see that the star edge from the bottom side is exactly what my dimensions were from my sketch. Let's pull this sketch back up. Right. My sketch of those lines are perfectly in line with the overall dimensions. The deformity is on the bottom side, on where this interacts with how deep that angle is. But when I come at it from a different angle, it looks deformed. But again, from the top down, it is 100% in line with the constraints of my drawing. Okay, so let's use this and let's see. This bottom of this curvature, since I manipulated this and I actually brought this down farther, this plug won't fit correctly into this cavity. It just won't. It looks like it because it's constrained on the top side. But when you look at it from the section analysis, it is nowhere close to being feasible for it to actually work. So you can see that this is too deep. So from here, like I can do a couple things here, and we'll get it to work. So let's go ahead and let's hide this body. We'll unhide the section analysis. We'll fix this bottom portion. So Because I know this is a known good, what I'll probably end up doing here is suppressing in my timeline this extrude. So I'm going to go ahead and just suppress it. That means it goes away. And when I suppress it, it should, no, it did. All right, let me, let's go ahead and actually the easiest way to do this is let's just make another body. We'll do 3x3. Let's go ahead and add some thickness to 0.75. We'll cut that profile out again. We'll remove that. And then that star, what we'll do is we'll cut it in. But before I cut that in, I'm going to bring this in just a little bit farther. So the press pull keeps everything in line for myself. So let's go ahead and I don't want it as deep. Let's bring this up just a little bit farther. I like it. We'll hit OK on that. And then let's go ahead and we'll cut this profile into the target body. So target body is my base, my male model that I want, or the female model. And then the plug, we'll go ahead and select that and we'll just cut it. And I'll make sure that this plug is kept. So let's hide the plug. And there is my cavity that we're going to machine into the actual into the base here. Let's go through. Let me go through the chat here and see if there was any questions that I missed. All right. Kimberly asked if I cut the stars with an end mill instead of a V-bit, would help keep the uniform of the wave. Well, yeah. So, and if you use it like a just an end mill that's straight up and down, you'll have to put an offset into your male plug and cut it at the same angle that you're cutting at, which would be 90 degrees. Depending on the tolerance, will be a little gap when you put the plug in all the way down, and how tough it is to actually get that in. And I've seen a couple people that press those straight V-lay or the inlays in, and they're at like 0.003, if not smaller, of a tolerance. And the glue will push up and it will seal it and it'll be in there. But when you really like dig into it and you look at it, you'll see that gap. And sometimes glue, depending on the the tint that's on it, you really can't tell. But when you get really close, like we definitely tell if it's not an actual V-carve. So the V-carve is basically the most preferred to get around that, to make sure that all the edges are very seamless. And let's see, Brooks. Have you tried using a tapered ball nose? I don't know if that was the question of in response to Kimberly. Yeah, so there's some considerations that you have to take into account for sharp corners, and the differences between that engraving bit and the tapered ball nose. That ball nose has a radius at the very tip. This is a tapered ball nose. This is a Armana 46280. This thing is a workhorse, and it looks like there's a fine tip on it. In reality, it's not. There's a radius there, and that's why they call it a ball nose. And this radius is, I think it's a 1/64th. When it interacts with an edge and it comes out, it's still not a direct point that you would get from a V-Carve engraving bit. The other Armana tool that I have, for this one specifically that I'll cut this surface out on, it comes to a direct point, and when it interacts with this edge, it will drag that fine tip along this entire edge, and it will engrave that out, leaving me with a very fine tip interaction with that surface. Let's see, Marcelo. Yeah, it's the same concept, Marcelo. There's a radius, and you really can't tell that it's not interacting with the edge, and it's not. It looks like a point, but there's still a radius there that it's engraving based on that ball nose. And when it interacts with the line, and when it exits out of the material, it will leave a very small radius. And when you sandwich a male plug into that, there'll be a little bit of a space where the fine edge that you had and the ball nose where it exited, you'll be able to see that. And it makes it really tough. And at the end of the day, it all depends on the application and what you're using it for. And really, it all depends. And when I do these test cuts, and you'll see when I do the 2D version, when I show the tool path for it, you'll see how that ball nose interacted with that space and how it drug along the edges of these chamfers. And so we'll bring that up basically now, because we're basically done, other than doing the female portion of this. So the easiest way to doing this is I'm just going to push this upwards, and I'm going to leave a gap. This gap is very, very important for two reasons. One is you got to have material out where you can, and especially if it's a flat, with this being a curved surface, it's a little bit different. But you want to allow space, because when you press it down, it's going to press all the way down, and you got to leave a little bit of room so there's no obstruction. And if you're using a tapered ball nose, there's a slight curve or radius on the bottom of the female cutout that you did, where that tool just couldn't get in there, and there's material that's in there. So if you leave enough room, that material, it doesn't interact with any of the surface, the bottom surface. The other thing that's really important about this is I got to cut this thing off. And so when I bring this up, it's still left that degree chamfer that I have. So I'm going to go ahead and hit OK on this. And I'm going to find the remove. Let's suppress this. Oh, the wrong one. Which one was it? No, wrong one. This one. All right. So now what I'm going to do, this male plug, this profile, I'm going to bring upwards. And this was the exact mesh that I had that cut both ends out. So this is the reverse side of this profile. I'm going to move this up 0.1. I'm going to hit OK on that. And now I have the contour of this surface being the same as this bottom surface, and the plug interacts with both. So I'm going to hide the bottom. I'm going to bring this top back up, and you can see that I'm cut into this, but it's not one, it's still two pieces. So I'm going to go ahead and combine these two together. So I'm going to use the combine tool. I'm going to use the target body, the tool body, and I'm going to keep the tool, and we'll hit join. So now it's all one piece. So there is my reverse cutout of that star. How it interacts with the bottom of that plane, and the cutouts for the inserts. So let's go ahead and let's do a section analysis of this. So let's bring back the two bodies. And I don't want to thread. Close that. Let's go ahead and inspect. We'll do section analysis. We'll check this face, and then we'll bring this in. Let's hit OK on that. Now you can see the plug interacted with the entire surface, and I have a clean version of where it interacted with both surfaces. The only thing that I haven't done yet is I haven't left a glue gap yet. And the glue gap is 100% important for the glue. The glue has to go somewhere. And if you don't leave a gap, the glue will end up pushing, it'll want to push that plug back out, and it will deviate from this line. The edges and how it interacts, it won't line up correctly. So let's leave a little bit of space on this bottom portion. So what I can do is I'm just going to go ahead and hide this bottom. We don't have to worry about section. You can actually do this with section analysis turned on. All it is just it's running in the background. It has nothing to do with this overall body. It's just a different view of that model. If you want to see how this interacts when I bring this up, yep, it can definitely do that. So let's go ahead and we'll press and pull this. Let's go 0.01. I'm going to hit OK on that. Oh, actually, let me hit undo. This is a pro tip on you got to make sure that you do new offset on your body. You can do it where it's automatic, and it will take your entire history of what you've been doing to that model and how it interacts with other surfaces. Or you can do a new one where it doesn't do that. It doesn't bounce it through the entirety of your history. The history that I'm talking about is on the bottom here. Every action that I do in Fusion will record it. And so if I edit way back in my timeline of a sketch and I do something, it will update this entire history to account for that one change. It's a great feature, but it can really throw you off if you only want to do something very specific at a certain time where it doesn't interact with the rest of the history. So when you're offsetting a face, always new face. So I'm going to turn the section analysis off. So let's go ahead and we'll bring this up 0.1. And so what it's doing is it's cutting this material off, and I don't have to worry about any of that. So I'm going to hit OK on that. Why did you make a new body? Oh, I had the male plug cut out. I'll hide that. So now you can see that it cut that material out, and it's good to go. So now, let me hit my home button. Let's bring back in the bottom, and let's check our analysis. So now you can see that I accounted for all of the glue gap. Now the glue gap interacts only with the bottom of the surface. The side of the angles downwards, it doesn't have that. So let me edit. Let me bring this analysis over to a different spot. So you can see that it still maintains that bottom, but not the angle. Only the bottom of that surface. Pretty cool stuff. And again, that plug is different on that surface the entire time. So it's it can get the reassurance of having the 3D model and where you can view it and you can do the analysis gives you that warm fuzzy of before I go into hard material. I know that there's a certain level of um, success rate, probability of success that this thing's going to be successful. Um, Very, very powerful tool. Okay, so that's basically it for the modeling to do that plug, how to do it correctly. And again, I'll put this file on my Patreon account where you can download it, you can interact with it, you can experiment with it. Definitely 100% free of charge. But the real results is getting into the garage, getting it onto the CNC, and programming and having the CNC actually cut this thing out. So what I'm going to do here is I'm just going to flip this male version 180 degrees, and I'll bring this over, and we'll bring this up, and there's my flip. So when I enter into the machine, these will be how my material lays into the actual CNC. Okay, that's the basics of doing that model, how to constrain that curvature and how the star enters in to maintain the actual distance and dimensions of the star. The hard part now is programming the tool paths. And there's a difference between a 2D toolpath and a 3D toolpath in Fusion 360 and how you set it up and how it interacts with the material and trying to make it work for what you want it to work. There's very specific settings that if you choose a different setting, you'll get a completely different result. So there's a lot of play. I spent a good portion of an entire day trying to figure out how to do the tool pathing for this. It's but once you get it, it's almost second nature and it makes sense after looking at it. Um, okay, so what I'm going to do is I'm going to close this out. I'm not going to save. I'm going to bring this back up. Okay. For the 3D modeling, that's basically it. Let's go ahead and we'll go into the tool pathing. And let's work on the 2D version first. And the process that I used, again, so I made a conscious decision just to try the tapered ball nose. And you'll see just how difficult, because this plug, just when you look at the plugs, how this angle is different than this angle, it threw me off because this is still this corner or this edge is 6.2 degrees on both sides. When I pushed these in, it changed this bottom, and this angle that you look at from the side is not 0.62 degrees that you would think of. It's different. And when I accounted for the tapered ball nose, where I couldn't have that really sharp edge, it changed the geometry and how it interacts with these edges pretty significantly and how the tool interacts with these corners. And so this tapered accounts for the taper, this corner, and how small it gets on the bottom, and then how it interacts and it cuts that material out. If I was to pull that tapered ball nose straight down, just along one edge, it's not going to cut this top portion out. all the way based on the radius of when this tool reaches that point. It still needs to carve a little bit out, and we'll kind of go through what that looks like. Um, but that's why these radiuses are here. This accounts for that tapered ball nose. It should, in theory, and I haven't tested it out yet, it should carve that exactly the dimensions that is depicted in this drawing. Okay, so the first tool operation that I did was just a basic clearing operation. And what I did is I made sure that I left meat along this edge. I wasn't really concentrated on this corner. And what I can do is I'll pull the settings up here. And this is just a basic 2D pocket, right? It's not doing anything crazy. I picked this, the bottom face that it was going to be constrained to. The most important part is my stock to leave, where I told it that it was gonna drill that entire bottom of that pocket out. Excuse me, the pocket out, but it was gonna stay 0.02 away from this wall. And when this wall, it's like this top portion of this wall is not 0.02. It's, remember, it's at an angle. When the tool comes down, it's going to stay 0.02 away from this bottom edge. So I can control how it interacts with that material very, very pinpointed, where I don't remove this material and I'm going to let my ball nose go in there and clear the rest out. I don't want it to interact with that edge. Not as important when you're interacting with the female body, but it means a lot when you start getting into this. And if you run that tool path and it hits that wall at the wrong time, it's gonna hurt and it's gonna chip out, and you're not gonna get the results. Okay, so I'm gonna hit cancel on that. Well, let's see. Yeah, the stock to leave. I did a 0.1 step down. Those were the only, and other than smoothing, I checked that. And what that does is it corrects jaggedness in your tool path. You'll notice a couple machines will start going like this, and because it's trying to follow the contour of the profile sketch. And sometimes it gets really crazy, jaggedy when you do that. So if you hit smoothing, it will account for the deviations, and it will be one really smooth tool path where your machine interacts and it's not so hard on it. For the linking, I made sure that it was a plunge cut and I didn't change anything else. What that gave me was a basic clearing operation to get that material out. And then it saved meat for my ball nose to go in there and eat that out. So the next one that I did was a 3D tool path, and it's called pencil. And what pencil does is it accounts for all the edges in a 3D environment where it will machine those really, really hard angles that you can't really get to. And it does a really good job on projecting it. If I was to use the engrave tool on this, because I'm using a tapered ball nose, Fusion doesn't like that there's a radius there, and it can't calculate what that radius is for the for the engraving. If I was to use an engraver on this, I would just pick engrave, and it would cut these angles out for me. No issues. As soon as I pick ball nose, it will air out and won't calculate that tool path. So because I'm using the pencil, all I had to do was select my tapered ball nose. When I came to geometry, I constrained it on the inside boundary of this edge. So no matter what, my tool will not deviate from that edge. When it goes down, it will hold that tapered, and how it interacts. Because again, this is smaller than this top side. Um, it will interact a certain way and it won't deviate, and it's completely constrained within this environment. From there, for my passes, didn't have to change anything. Um, I did change this. I told the, and this is, it's an angle and degree in which the taper ball nose enters downwards, or the degree of cut. I just matched that with this overall tapered angle. And another really good point, and I'm going to bring this up because this took me a second to figure out. Let's deep dive into this tool and why it's so painful trying to program these things in. The tapered angle is 6.2. Okay. Your 30, 60, 45, or whatever, engraving bit that you use, it's the overall angle of that, right? When you divide it by 2, it'll give you, the 90 degrees based on whatever that angle is. And so for a 30 degree, even though it's 30 degrees like this, it's 15 when you account for the other half. The tapered ball nose isn't like that in Fusion. And what it does is it accounts for the half of the overall angle. So it's already programmed into 6.2. Being intuitive, you would automatically think, well, if this says it's 6.2, I would divide that by half, and that 3.1 would give me this angle on this side. That is not true for this bit, in Fusion anyways. So the middle portion, that's 90 degrees, and this angle that's coming off of it is 6.2 degrees. So I made sure I captured that on how the tool interacts with that chamfer. So that's why I set that to 0.62. And I made sure that I clicked smoothing, and then my retract policy, I kept it at a minimum. When I hit OK on that, it brought in this cut. So it plunged all the way down, and it removed that material on that wall, and it followed this profile. And it used the entirety of that tool to do that. So let's go ahead and simulate this. So I have this as transparent. Let me get back here. So this is the excess material that didn't get cut prior to the previous tool path that I used. And then you can see my edge of the overall model. So let's go ahead and we'll run this. I'll make sure the accuracy is turned down so it's not so choppy. We'll turn this down. Okay. So you can see my ball nose, that radius. This radius should match and how it interacts. We'll go a little bit faster. And you can notice that it did a little bit of a spiral here just to make sure that entire area was hit. It's taking it along that edge. And we'll speed this up just a little bit. And it's hitting all of those lines, and it's machining, and it's constrained on that wall. Now you can notice that it skipped this corner. It's going to come back later, and it's going to gouge that out. And it comes down to tool deflection, and I really like that it stopped and it didn't hit that, and it'll come back later and it will take it out. Let me show this. We'll go back on this corner. Let's check this corner out. This radius, 6.25 or 6.2 with a with a fillet that matches the overall profile of this tapered end mill. Comes in, it has the touch points on that corner and it has the touch points here. And then what I'll do is I'll come back over and I'll make sure that these corners are 100% cut out. Okay, now there's still a little bit of work here. What I ended up doing with the same tool, I came in and I ate the rest of the material that when it did that profile, it left. It was a couple islands that it needed to come in. So same concept. I used a 2D pocket, came in with the bottom surface, but I made sure that I hit resting. And the tool diameter depends on the prior tool that you used. This default of 0.2 made my tool path a little bit more rigid, and it hit a little bit more area to make sure everything was cleared out. With this, because the majority of the material is already out, I didn't have to do a step down. So it's going straight in, and it's just going to clear that material out. I changed the ramp instead of a spiral to a plunge, and I hit OK. And what it did was it came in and it hit the previous islands that were left over. So we can simulate this. And yeah, we'll come right in and it just eats that material right out. Doesn't interact with the wall. And if I wanted to be really careful, where I didn't want to hit it, I could define that it cannot touch that wall. I can put a hard constraint on that if I wanted to. But again, it's not eating any material out, other than those small islands that were left over. Okay, so that's the female portion. Now for the 2D version, it's basically the same thing. I used a 1/8" end mill, and I came in and I cleared all this material out, but I made sure that I didn't interact with this edge. So I left an offset of 0.01, and the offset is the bottom. And then I wanted to take all the radial stock out. It's gone. The question that most people will ask, and I had to double check this again, is remember that I took material off the top of the star to give me my glue gap. It was like 0.01. When I did my initial setup for the stock, we'll look at it from the other portion. My stock is zeroed right on the top of this surface. So when it does this machine and it eats all the material out, it's already accounted for in the overall setup. Say if I didn't want to account for that, and I had I don't know why you would want to do that, but you could come in here and do, you could add stock, and you could see that it left a little bit of skin on the top portion. That other tool path will account for that, and it will clear that off, because again, you have to come in and take that material out. Easiest way is just make sure you don't have any additional stock, and you use the top of that 0 as the bottom of that cavity. Okay, I'm gonna hit cancel on that. And all right, so that's the tool path. It left a skin along those edges. And then I came back with the same tool path of that 3D pencil, and still having my tapered ball nose. My machine boundary was, I actually used a different thing. I didn't put a boundary on this one. I used the avoid machine surfaces. So I came in And what we can do is I'll edit this. And so you can see this. I can't remember if this is available on the free version. I'm on a paid version. So I can literally go in and I can depict what edge, what surface, what, portion of the drawing that I want to machine. I don't have to let Fusion guess on what I actually want to machine. I can hard constrain it, and select each one of these faces for it to come in and do it. Um, and you can do the opposite, where you can say, I want you to avoid this corner or this edge or whatever the case is. You can define that in that toolpath. I'll hit cancel on that, but regardless, so I constrained it to where it's only running along this corner. Same thing with the 6.2 degree angle. No multiple step downs, and I kept my retract policy at a minimum so the tool would stay down. And then this generated this. So let's go ahead and we will simulate this. Now, this radius, a little bit different. The tool understands that this radius is still a little limited, and extra attention needs to be taken into account to make sure all the material is removed on this. And again, this is the bottom face, not important, but you can see how it does take it into account. All right, so we'll slow this down. Enters into the surface, and then it's going to come back up. It can't hit this radius for some reason, can't hit exactly where it needs to be. So it's going to do a couple passes here, and it's going to make sure that everything is cleaned out. Once it does that, it will go into the normal tool operation, and it will take this entire radius out. That is the male plug for that insert. And again, it's going back in and it's just massaging those corners just to make sure all the material is all the way out. Now, while this is working, you can see that there is a little bit of material on this bottom side because of that radius that it's doing this when it cuts it. This is the reverse side of that cut. So this would technically come up and it would plug in. I left 0.1 distance in between this edge. Well, actually, you can see it here. So this is the surface of my female surface here. I left that 0.1 to account for that distance of that radius. So no matter what, it's not going to hit it. It's not going to, when I sandwich it down, it's not going to bind, or it's going to be in there. Definitely have to put that into consideration. And that's it. That is the 5 tool pass for the bottom and the top is 100% done. This should fit into that crevice and touch exactly where it needs to touch. And when it glues in, I should have 100% tight glue seam. The 3D version, it's basically the same thing, other than I have to cut this 3D profile out. So before I decide to go in and cut that crevice out, I'm going to just go ahead and I'm going to put that 3D profile with a tapered ball nose, and I'm going to cut all that out and produce that surface. After that, I'm going to come in with my normal operations that I would do for the 2D, clear all that material out, leaving the thickness around the edge. And then I'm going to do the same operation for the engraving. And now the pencil tool doesn't matter. You can have a tapered ball nose, you can have a engraving bit. They operate at the same constraints, not like the engraving tool. So so with this, let's run this, and you can see how that engraving interacts with the edges. All right. Now you can see it left a little nugget there. If I'm looking for a tight, really, really tight, you know, um, joint, that little deviation, it's going to shift and it might not fit correctly, or it might not be as seamless as you want. What this bit is going to do is it's going to come back in and it's going to eat that out. Same concept as we had for, for the 2D version. Um, and see if I can capture this. Eh, this. Oh, that's okay. I know why that's like that. There's a there's an accuracy setting in simulation, and this is actually really good to know. If I turn my accuracy all the way up, it will account for uh, exact measurements of that model. If I turn it down, there's a little bit of deviation there. The difference is if I have it down, it's not as labor intensive on my computer. If I have that all the way up, my computer will get really choppy. Um, but same concept. It did the other corners just like it. Um, but tight corners, the walls are completely done, and it had that 15-degree chamfer all the way where there was contact with the engraving bit and that wall. Um, Let me exit out of this simulation, and I came back in with the same bit because I don't want to change out tool bits. And I came in and I cleared out the rest of those islands. Um, these are not long tool paths at all. The that engraving of that outline of that star was 13 seconds. The other one was a minute. The 3D profile cut was about 10. So not bad ish. Um, and then let's go. I'll show the male side. The male side I cleared because I didn't want to touch that star. And there's a this bottom here is about 0.75 inches of material that I don't want my tapered ball nose to come in and try to clear that out in one pass. So I removed a bunch of material, and it just makes the 3D carve just a little bit better and a little bit easier on on the tool. What I did do is I used the same concept for that parallel. So when it's going in and it's doing these parallel passes, it's skipping everything that's along this star, and then my engraving bit will come in later and it will clear that out. But I did not want that to interact, and it got really close. There was a couple of points where it started to come in, and this tool that I'm using is a straight. It's not a tapered ball nose, but it's a straight ball nose, and it's a quarter of an inch, and it's hogging out a lot of material. All right, so let's look at the pen tool on this. So same concept, same settings, nothing changed. Um, and then we'll show the interaction along this edge. So again, entering at that point, excuse me, at that point, coming along and clearing out the majority of this material. Now, what you'll notice is this is material right here. I am still 0.1 above where the bottom or these walls will connect. So this is still no concern that I have material that's here. It's just excess material that I didn't want that ball the ball nose to interact with. And it's left over. Again, not an issue because it will never contact it because it's 0.1 above it. Matter of fact, let me put off transparency and you can actually see the crevices. So it went in, but it left that ball nose degree, that radius in there. So when this gets put on, you'll see this, in between the little slit of that 0.1 deviation, and it won't touch that female portion. Um, but that is basically it. When these things come together and they glue in, what I'll do is, let's get out of this. I will create another tool path. I won't do it here because what I'm waiting for is the final distance of the female plug in relation, or the male plug in relation to the female bottom. I know the distances of my male bottom, but I think there'll be deviations on the male side. Um, on the overall thickness of where I'm at with my Z height on my CNC machine. Once I know that dimension, I'll come in here and I'll model it, and then it will come in and it will clear everything out, and then it will put the same profile of this um, as its own separate cut, and it will cut all that topping off. Should be pretty fast, but I just don't know those distances yet, the thickness of the material. But once I get it in the machine and I have the raw materials in my hand, I'll be able to know pretty quick. That's why I haven't programmed that in yet. But that should get me to this, where the plug is in and the plug is in for this, and it should, in theory, if everything's done right, and tool deflection, accuracy of the CNC machine. Again, I have a belt driven drive, so the belts I got to take into account to where can't go as deep and as fast as I want to. But if I take into all that into consideration, I should have 100% tight seams on those inlays. So the whole purpose behind this was one, just to prove that it is possible in Fusion that you can model it and you can do all the tool pathing and you can actually create it. The other purpose was to actually make a big wavy flag, and I will V-carve inlay maple into the union on that. So we'll do a proof of concept just for the test fits. I have some walnut. I'm probably gonna. I got some excess curly maple that I don't have a purpose for. So this will be curly maple. This will be walnut. And the curly maple, if I was, I'm planning on using the curly maple for the big flag, and I just want to see how well the edge lined up with the material of the curly maple. Curly maple, it's really hard, and the curl it's brittle, and I just want to see how it interacts with it. If it chips out right away, or if, something really crazy happens, I can put all that stuff in there. So that'll be the test cuts. And what I'll probably end up doing is I kind of showed this just earlier. I didn't go into depth, but doing the same thing on curves, lettering, getting the same result, but getting that into the 3D portion. And again, I mentioned earlier that drafting tool has some limitations, and the limitation is this spline, this curve, and it doesn't like it. And there's some things that I can do to overcome that, and how the actual drawing interacts with the surface. So I've been playing around with that. I think I figured it out, but that will enable some really cool lettering and some other really intricate inlay design work. So definitely not impossible. Would most people say that this is preferred or not preferred? I'm still on the fence on it's probably not preferred, because V-Carve Pro can do this really, really fast, and you can input exact parameters on how much glue gap you want based on the surface. a whole laundry list of things, and it calculates it very, very fast. This goes through a more methodical method of doing that. But again, this was all to correct the star being deformed. And this is the only way I could figure out how to do that. So definitely not impossible, is possible. So let me go through the chat log here and just see if I didn't miss anything. If you left a comment or a question in there, I'll dig it out. Um, let's see. Sharp corners. Yep. Um, I got the taper ball nose. Let's see. Let's look at this one. Nature Live Edge. I think you should give the curly maple a shot as the wave reflection on light and stars. Yes. Um, Very, very true statement. I love doing wavy flags with curly maple because the light hits it at a certain, it shifts. So as you're shifting around the light and how you visualize it, it looks like it's wavy because the light's hitting the curly in a different way. It's super awesome. This flag is just pure hard maple and it doesn't have that same effect, right? If I shift the light, it's just, this is the color you get. And it is what it is. But man, curly maple on a wavy flag, it looks spectacular. It looks really good. Uh, yeah. So hopefully I didn't miss any of the comments. Definitely really appreciate everyone that tuned in and just kind of did this quick overview. Again, this file will be available once I get it tested and I know it actually works. It'll be on my Patreon for free, and and that just talks about another thing too, is the files that I do sell on my Patreon. Those are all valid, tested, built. 100%. I will not put a file on that site without me building it first and making sure the tool paths are generated correctly and there's no issues that arise when you actually build physical material. So that does mean a lot, especially, I see files that are getting shared constantly and it's just, somebody just made the file really quickly and posted it. And I'm, you know, is it successful? It probably is, depending on the work level and making and verifying everything. But I verify everything before it goes on there. And then, so when I do make this, I'm going to do an entire build video and then a walkthrough on Fusion that we just did here, step by step, without me mumbling and, actually having a script. This is all live, and I don't pre-rehearse anything. I don't have topics. I'm just talking through the process. But the build video, it'll be more methodical and without me mumbling. Let's see. So that's basically what I got going. So that video should be posted probably Monday, if not Tuesday. I'm going to finish up these inlays today and get everything test fitted. And then next week's video will be the wavy flag, big flag video with the inlaid stars that use this methodology and implement it. So those are the 2 weeks. And then I got a couple other videos that I'm doing. I'm still working on these freaking puzzles. I got puzzles everywhere. And I don't know if I lost interest in it. But I'm almost at the home stretch where all those puzzle pieces will get done, and it'll be an easy, medium, hard, and like, what the heck is this, type progression. So that'll probably be end of December into early January, and then a whole laundry list of videos on a CNC machine that I'm getting ready to purchase. I think I've landed on Stepcraft with the automatic tool change and some of their systems that they use. So I think I'm going to bite the bullet on that and get that purchased probably early next year. So that'll go through. Nature, I'll put a link to my Patreon in the comments. when you go in there, you can you have to be a member to Patreon, and it's free. There's a whole laundry list of different creators that are on it. A whole lot different, personnel doing different things, selling music, all this other stuff. But for mine, um, it'll just be all the woodworking stuff that I put in there, all the files and everything like that. And I think there's a join portion, and you have the option you can join for free, or if you want to support the channel and everything else, there's a $20 membership. Depending on what you guys use Fusion for, it's not, at the end of the day, the files are kind of cheap enough. But if you do the $20 subscription, all the files, everything that's paid for is completely free after that. So I had some really good reviews as far as people using the files and how successful they've been on it, especially with other softwares importing it. But then there's a couple times where those files are just a little bit more advanced than another software that they were trying to use. And I try to walk and help as much as I can to get it successful for whatever platform or whatever software you're using. But again, it's how much effort you guys want to put into it. And like this, there's a huge learning curve. One, to operate the CNC, and two, to do all the programming and everything like that. So, but yeah, I'll definitely put the link in the description. And Kimberly, can waves be done on V-Carve Pro? Yeah, actually, I'm not 100% sure. I would default to somebody else that's more familiar with V-Carve Pro. I'm not too sure. So when you start going onto a wavy 3D surface, things get really, really, really complicated really, really fast. How the plugs interact. Just modeling this took a little bit of time to really figure it out and how this plug entered into the surface. And but again, that's why a lot of people's stars are just disformed and or deformed. And but there's ways to overcome it. I just don't know if V-Carve Pro will do that for you or not. I think Vetric, if I remember correctly, you can project a sketch, a drawing onto a surface, and it will project it downwards. But then how you interact with that, with the tool pathing and everything else like that, I'm not versed in. So I think eventually, I'll maybe subscribe to Vetric and V-Carve Pro and start playing around with it. But right now, I'm pretty invested in Fusion 360. All right. I don't see too many other questions. I think I hit the majority of everything. Matter of fact, before I forget, let me send the link. I'll put the link to Patreon in my account. No pressure at all. I'm not a salesman. I'm not trying to sell, constantly or anything like that. I'm just trying to give as much information as I can. And but all my files right to that website. And yeah. Okay. Yeah. No. I think it can project, to be completely honest. But again, I'm not 100% sure, Kimberly. Yeah. All right. So with that, I'm probably gonna sign off here, and I'm gonna jump and get my camera ready, and I'm gonna start documenting this process with physical materials. So can't thank you guys enough for watching the live stream. Definitely a huge shout out to Mark for giving me a cool plug. It really does mean a lot. And yeah, with that, happy Sunday. And I'll see you guys next week. And just be on the lookout. Please subscribe. Definitely be on the lookout for this video on how I make this. So, cheers and happy Sunday. And I'll see you guys next week. All right.